Hello everybody. Just gonna knock out the second video on some simple little trig review that I want to make sure you're squared away on before we move on to limits and continuity. So probably again go through this pretty quickly, a little quicker than what we would normally do. Be mindful of your time. I think you're gonna remember all of this. It's definitely topics that you've seen in the past, but with remote learning at the end of last year, knowing that we need to move forward and know how to do all these topics, I do want to go over this a little bit. So if you have the worksheet in front of you or the notes in front of you, just kind of follow along, and I think you'll have a pretty decent time with this. So we'll start. So with the trig review, day 2 is just kind of worrying about sine cosine graphs, what they look like in general, how we can manipulate them, stretch them vertically, horizontally, okay, all that good stuff. So what I'm going to have you do first is label this x-axis with 90 degrees along the unit circle. So pi over 2, 3 pi, 3 pi over 2, and then 2 pi. And then the way you probably did this initially is with a simple little XY chart. This will be a good review of your unit circle a little bit here too to know what these are. If I ask you what if the x value is 0, you're going to find the sign of 0. That basically is just telling us on our unit circle over here at 0, sine is the y coordinate at that angle, and your y coordinate over there is going to be a 0. And then we can plot that point. If we go to the next point that I have along the x-axis, which is pi over 2, that's the top of our circle. The sign of that point is the y coordinate up there. That's going to be a 1. So over here at pi over 2, you're going to put a dot at 1. The next value we're concerned about is pi. On our circle, the y coordinate over here is a 0 again, so that drops us down to here. We're doing this pretty quickly. We should know the sine wave graph, or the sine graph is that wave graph. So while I didn't put in pi over 6, pi over 4, pi over 3, when we connect these, we should know it's this general shape of the sine wave. So when you sketch that in, make sure it's curved. Don't just connect those with line segments. If we do 3 pi over 2, then that takes us back down here on our circle is a -1. So that's why 3 pi over 2, our y value is a -1. And then at 2 pi, we should be right back at 0. Finish that. That's our sine wave graph. That's the basic sine curve. If you would notice, this doesn't have any shifts. It doesn't have any stretching vertically, horizontally. We'll get into how we can do that. That's what our basic sine curve would look like. For the next one, if we did the same exact thing, x, y, let's label these the same way. This is going to be 0, and then pi over 2, pi, 3 pi over 2, 2 pi, but then you'll notice we got to continue on. I made the x-axis a little longer. So 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, and then 8 pi over 2 is 4 pi. Careful how you evaluate these. Sometimes people get the order of operations messed up. What we want to do first is multiply the x value by that 1/2. In this case, it wouldn't matter because you're going to still be doing the sign of 0, which is going to be a 0. The one you want to be careful of is if we now throw in pi, let me erase this, in our table. What we want to do first is do half of pi, so pi over 2, and then we want to take the sine of ultimately pi over 2. We've already did that up here. The y coordinate up at pi over 2. No, I'm sorry. Back it up. Our next value is pi over 2. So already -1 for Mr. Pena. So pi over 2 is our next value along the x-axis. So what we're really looking for is the sine of pi over 4. So sine of pi over 4 is going to be our √2 over 2, which is approximately 0.7 as a decimal. So at pi over 2, we'd go up about 3/4 of the way. Then we go to pi. And then what I was showing you here a minute ago, we want half of pi, which really then is pi over 2. The y coordinate at pi over 2 is our 1. That's what we had done in the previous graph. So now we're up here to 1. And then if we do 3 pi over 2, and same here, we want to first do half of 3 pi over 2. which is 3 pi over 4. That's a new point that we haven't talked about yet. Here's 3 pi over 4 on our circle. If you look at the top there, that's also a root 2 over 2, which is our 0.7-ish. Looks like this. And if we did our last one, 2 pi, I ran out of room on my table over there. But if we did a 2 pi, then we would want half of 2 pi, which is going to be pi. Sine of pi is this 0 again. So if we now look, we have the top half of our sine wave graph. It took us a length of 2 pi along the x-axis to get the top half. So if we went ahead and did the bottom half, if you want to go ahead and use our xy chart for all of these, you would find that the 3 pi gives us that -1. 4 pi is going to take us back to 0. And then that's going to stretch us out. So what we did, if you notice, the sine curve still goes through the origin. So if there's no vertical shift, horizontal shift, we're still going to go through the origin. But what it did is it got stretched out horizontally. Instead of taking 0 to pi, I should have read the directions here too, completing 1 full cycle. So this is 1 full cycle. The next time this one went from negative to positive took us now 4 pi over here. So that's why we stopped there, because that's 1 full cycle. So we stretched that thing out horizontally. If you notice, our amplitude is still the same, the up and the down. We still go up to 1, -1. So what we would want to make a note of, and we'll formalize this on the next page, if you don't remember, this number here, if we throw a coefficient for x, it's going to stretch us out or shrink us horizontally. If we look at number 3, notice the coefficient of x is back to being a 1, just like it was in that first problem up here. Notice how this took 2 pi to finish. So anytime our sine function has an x coordinate with a coefficient of 1, we only need 2 pi to finish our cycle. So we're going to go 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Make a little xy chart. This one should be pretty straightforward. 0 we know is 0, but we then want to double that. So still 0. If we go to pi over 2, like we did at the top, the sine of pi over 2 is, this here is a 1, but we're going to double that. So that's why we're going to get a 2 now. We're going to stretch it vertically. If we throw in pi, get rid of this guy, you're going to get 0 again, so it brings us down here. If we did 3 pi over 2, the sine of 3 pi over 2 is a -1. So we got 2 times a -1. Drops us down to a -2. And then if we did 2 pi, you're going to end up back at 0. So same type of shape. It's our sine wave graph, but now we got stretched vertically. All right, if you remember, that's called our amplitude. How far up and down do we go? So the number in front of our trig function would tell us how far up and down we're going to go. So this was 2, so that's why we went up to 2, down to 2. This was a 1, that's why we went up 1, down 1, up to the +1, down to a -1 overall. Here, the original, the coefficient was a 1, so that was our amplitude. We go as high as a +1 and as low as a -1. Okay. Cosine graphs look similar. And again, we'll do this with our xy chart first. If I do 0, y would equal the cosine of 0, which is 1. So we now start at a little bit different place. Sines are going to start at the origin, or at least cross the origin, as long as there's no shifts in them. And then the cosine is going to start at 1. If we do pi over 2, the cosine of pi over 2, and again, we're just getting these off of our unit circle. The x coordinate at the top of our circle is 0, so now we're here. If we go to the pi, the cosine of pi should be a -1 from our unit circle. And again, this almost looks linear. Don't draw it out as being a line. Make the wave graph that we know this would be. When you were learning this last year, you would have done a lot more points than we're currently doing. We know it's that shape. So we're cheating now. If we go to 3 pi over 2, the cosine of 3 pi over 2 brings us back to a 0. And then if we did the 2 pi, should bring us back to 1. The reason that's considered one full circle is because at this point where I started, we would have been going from increasing to decreasing. And the next time that would have happened over here, if we would have continued on, we would have started to decrease. And then we just repeat what's going on in between 0 and 2 pi. So if you keep in mind, this had a coefficient of 1. That's why we only went as high as 1 and as low as 1. We have a coefficient for x of 1. And that's why we still finished in this 2 pi. Last one then, last thing that can happen. So let's talk about general things real quick. Since we see that the x has a coefficient of 1, we know we're going to complete a full cycle in 2 pi. That's going to be, well, we'll call it what it is here in a minute, but that's going to be how long it takes to complete a full cycle. Since this is a -2 in front, that's going to tell us that we'd be bouncing up and down between a +2 and a -2. The difference being this is a negative coefficient. So usually I kind of ask, what would that do? People typically understand that the negative coefficient in front of our trig function flips everything. If you don't remember that, we can always rely on a little XY chart to graph pretty much any equation that we need. The cosine of 0 is 1, but then you have a -2 in front of it. So that's why this guy's going to start here at the bottom. Pi over 2 would still be 0, and then if we understand we're going to go up to 2, 3 pi over 2, -2. It's like we said. We wouldn't have had this because we just wanted one cycle, but then we would get our sine curve just flipped around. All right. That's how you probably did that at the beginning, just with XY charts, a table of values, and being able to plot them. And eventually we want to shorten this up so we can just look at them, graph them, or be able to identify everything. If we look here and here, this is everything that we can do to our trig graph. We've talked about A being how we can vertically stretch or shrink our graph. The B is the coefficient. If we were to distribute of your x, that B is going to determine us stretching it horizontally or shrinking it horizontally. And then the minus the C. So if we add or subtract something from x, if you remember with parabolas, absolute value graphs, trig graphs, that's a horizontal shift. And if we tack on a constant at the end, again, with parabolas, absolute values, trig graphs, any graph really, exponentials, that's a vertical shift. So I mentioned this earlier, the amplitude is your A. So if you look at where the A is, it's the coefficient of your trig function. The absolute value of that is defined as your amplitude. If we read through all this, it's stuff we've already talked about. Vertical stretching or shrinking. It's going to give us then the range being our Y values that we're going to hit. So from +1 to -1 if our amplitude is a 1. And then we talked on that last problem on the front page, if A is a negative, the graph's going to be flipped. So this is as easy as it gets right now. It's going to take us about 5 seconds. If I ask you for the amplitude of these 3 problems, since that has a coefficient of 1, the absolute value of 1 is a 1, that's our amplitude. Amplitude here is the absolute value of that 1/2, which is 1/2. And then the amplitude of number 8 is 3. All right, and that's pretty much it. The period, if you remember, the period determines your horizontal stretching or shrinking of the graph. The period shows the distance on the x-axis where the graph will complete one full cycle. If you look at these are, at least 2 of them, are ones that we did on the front page. So this is the one that we did on the front page, very first one. And it took us 2 pi, from 0 to 2 pi. So our period in this one, we would say is 2 pi. We can do that. We can know that by looking at the graph. We just look and see when does it complete a full cycle. If we don't want to have to graph something, or we don't have the graph available to us, here's how we can find the period of sine and cosine. So for this one, you do 2 pi over b. B is the coefficient of your x. So if we divide this by 1, we would see that our period was 2 pi. We did this one on the front page. This was number 2 on the front page. If you remember the period in number 2, that we can look at it. This is the problem we're doing now on the second page. It took us 4 pi to complete a full cycle. So that's what this little formula should give us. Our period should be 2 pi divided by b, where b is the coefficient of your x, which in this case is a half. Divide those, we get our 4 pi like we know. So let's cut to the chase here. Let's not make this any more painful than it needs to be. This is 2 pi, and then the b is 3. So that one, if we were to graph it, would 2 pi over 3 would be how long it takes to complete a full period. Horizontal translations, this applies to, like I mentioned earlier, pretty much every graph. If we start adding or subtracting values from x, it's a horizontal shift. So if you'll remember, if we do x minus 4, that's going to shift this graph right 4. Whereas if we add, that's going to shift us left. One of the things I would recommend is let's always create a coefficient of 1 for x. I think it makes some of the problems that we're going to do here in a minute a little bit easier. So let's factor out that 5. Then you'd be left with 2/5 here. And what we can now see, since we are adding 2/5, that's going to move us left 2/5 of a unit. And then 14, same thing. I would pull out the 2 so that you end up with an x minus 3/2. We can then say, since this is a minus sign, that you're going to be moving right. And then we see that we're moving right 3/2 of a unit. Vertical translations won't get much easier than this. If we're tacking on a constant at the end, it's a vertical translation. So a positive 4 means you're going to go up 4. That negative 2 means we're going to go down 2. This positive 5 means we're going to go up 5. Those are arrows. I do actually write better on the board. I apologize when it's on the computer. And then this one, we go down 4. All right. What we then typically do, I give people a minute to see if they can kind of go through all of these and try it. So if you want to pause me and just make sure we can do these 4. It's a little trickier when they get put all together. Not terribly hard, but then you have to keep everything straight. So if you want to pause me, try it, go ahead. If not, we're moving on. Amplitude here is the absolute value of this number, so that's 4. Our period should be 2 pi divided by b. B is the coefficient of your x. In this case, your x is a 1, so our period would just be 2 pi. Since we have x minus 3, this is going to get shifted right 3. And then we're adding a 1 means we're going to go up 1. Amplitude, here's our coefficient of 1. So our amplitude is a 1. We want that absolute value. Although, let me go ahead and do a little work here. I'm going to pull out that 4 so that we have x minus a 1/4 and then minus a 3. So our amplitude is still 1, but our period should now be 2 pi divided by b. This is your b. That's our coefficient of x. Even though I pulled it out, it's really being distributed. So we divide that by 4, and you're going to get pi over 2. Our horizontal shift, the reason I have a p here, it's also sometimes called a phase shift. So PS is a phase shift, a horizontal shift, they're interchangeable. Phase shift to the right 1/4, and then our vertical shift is down 3. All right. 21 and 22. I also usually give people a little bit of time to try this. If you wanted to now try and figure this out, I'm asking you to write all possible equations. So that means there's more than one of the sine function with the following characteristics. So again, if you want to pause me, try it, feel free. Try to get more than one equation though. All right, so now, since it's going to be a sine function, and the reason it's a sine function is I specifically tell you it is a sine function. So there's our sine function. We have an amplitude of 5. So here's how we're going to get 2 different equations from this. The amplitude is an absolute value, and we know that that is equal to 5. So there's really 2 different numbers that have an absolute value of 5, and that would be a positive 5 and a negative 5. So that's how we're going to get multiple equations here. Both of these equations, this one and this one, we would say have an amplitude of 5. We then need our period, we need our b for the equation. So it's 5 times the sine of bx. If you can do it in your head, feel free. These are not overly difficult. What I like to do though, to formalize it, so we don't get caught up in thinking too much, is if our period is equal to 2 pi, if we know that our period is pi, we can set up this little equation here. Plug in pi for our period, since I'm telling you that's what it is, and then we can solve this for b. So if we multiply both sides by b, divide by that pi, what we would see then is that our b is a 2. So then over here, same exact thing. This b would also be a 2. So they look very, very similar. It's just they have a different coefficient, 5 and negative 5. All right. 22 I would try. This is the type, usually if I give a quiz on this, this is one that people tend to have a harder time with. If we're going to write that equation. Another way that we can do the positive 5 and the negative 5 together and save ourselves a little bit of time is just put a positive negative in front of this. And then that's really 2 different equations. And then we need the sign. And then what I would do is I would pull that b out and then understand we're going to do x minus c plus whatever our vertical shift is. So the vertical shift is pretty simple. So we come over here, since we're going to go up 1, we would want to add 1. Since our horizontal shift is right 2, that means we would do x minus 2. And then the last thing that we need to figure out is what is our b. The b we get from our period equation, that the period is equal to 2 pi divided by b. I am telling you in our problem that our period, so I'm going to erase the p for period, and I am telling you that your period is 4 pi. So we're going to plug in 4 pi into that spot, and then we can solve for b. Okay, so multiply both sides by b. All right, divide that 4 pi over, so we get 2 pi divided by 4 pi, and our b is a 1/2. So we go to our equation. That's one version of your answer. Here's the only other way to write this, and be very, very careful when we write this. We would get plus or minus 5, and then you could, if you want, go ahead and have that 1/2 distributed as 1/2 x minus a 1, and then plus 1. Either one of those two is okay. Okay? Lastly, being able to look at a graph and be able to decipher all that information. So with these, when I tell you that we're going to assume there are no shifts, the reason I want you to do that is so that when we look at this graph and we know it goes through the origin, up here I told you to use the sine function. Here I'm going to make you look at the graph and know which one, and since there are no shifts, if we're going through the origin, that means it's got to be a sine curve. So we know we're going to have the sine curve for our equation. Our A is our amplitude, or absolute value, that's our amplitude. If we look at this graph, we're going up to 2, down to a negative 2. Since we immediately start here and work our way up, we know that 2 has to be positive. So we're going to put that in. And then we need to figure out the coefficient of our x. What's our b? So to figure that out, our period is always 2 pi divided by b. And if we look at this one starts here. Notice how we're going from negative to positive. The next time that happens is over here at 8 pi, where we're going from negative to positive. So that means 8 pi is how long it takes us to complete one full cycle. So our period in this one, I wrote that a little too close, is 8 pi. Let me squeeze that in there. And then we solve that to get our b. So b should be 1/4. All right. Last one, 24. Notice how it doesn't go through the origin. That means we're dealing with the cosine. And again, we're saying that because we don't have any shifts. And if we don't have any sort of shifts, the sine curve should go through the origin. This one doesn't. We know it's a cosine. We can look at how far up and down we go. So we're going up to a positive 1. We're going down to a negative 1. However, since this one is starting here at a negative 1, that tells us that our a needed to be negative. So we'd have a negative 1 times the cosine. We would need to figure out our b. The period is equal to 2 pi divided by b. So if we can look at that graph and determine what the period is, that's what we're going to slide in for p. So here, the next time we're going to hit this low point in our graph, if we kind of cruise around this equation, would be right here. So our period for this one is pi. If you solve that equation for b, b is 2. And then that would be our equation. All right. So again, hopefully this is coming back to you a little bit. Nothing terribly difficult, but just want to make sure you understand all that, from day one, from day two, all stuff that you're going to need to know. All right. So with that, I'll leave you be, and we'll see you shortly.